Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. So, first up, we have a bit of a follow up or clarification, however you want to call it. And this is on a bit of the Next.js drama around the middleware bypass that we covered. And that was the fairly straightforward bypass where you could pass in the X middleware sub request header to effectively just bypass or shortcut the middleware in Next.js, which in the case it was covered in that blog post could be used to short circuit the auth, but could also be used for other things as well. And part of why this is coming back up is in our Discord, somebody had brought up the fact that there seems to be some misunderstanding and a little bit of drama around this issue. And that includes on the detection side, which is why we also have an asset note post up here. And Z, I'll let you get into some of that first.
Yeah, so when it comes to the detection side of things, it's disappointing. I mean, I'm not entirely surprised by this. And yeah, this post that we've got up for this week here, doing the due diligence, analyzing Next.js middleware bypass, it focuses on just the detection of it. That something detection, or like, I specifically think they call out here a nuclei template. I thought they had a link. I'm not seeing it right now. Yeah, all publicly disclosed down here. All publicly disclosed checks we were able to find that discover this vulnerability rely on the application presenting some rewrite logic in order to determine whether or not middleware could be present before attempting to exploit this. And they rely on certain checks that may not be there. And so this post is really just about building a more reliable check. It's a little bit disappointing that you see, like, they call out here initial POC suggesting the bypass was as simple as just using the header of X middleware sub request true. Kind of talked about this when we covered the original bug, where there were some complexities over what the actual middleware sub request, what this header's value actually needed to be in order to have an effect. So yeah, I mean, it kind of reminds me a bit of how you'll sometimes have people rushing to put out a POC for a CVE. I guess it is. It's pretty much exactly the same thing. Major bugs are just going to push out anything that's maybe going to work, even if it's bad code, because they get that little, I don't know, they could put it on their resume, I guess. And like, being real, most people aren't actually going to check if like their POCs work. So they get to say they have the POC for it. And maybe even that has a ton of stars on GitHub because people are going to star things without actually testing it. It's like, oh yeah, this is this. Try it. Oh, it didn't work. And there's that whole thing. But yeah, and then the detections, just another bit of disappointment, I guess. That someone
Yeah,
would write a
it's a
detection.
little. So it's kind of unfortunate because with like social media and Reddit and everything, it encourages this must be first attitude where it's like, even if it's not the highest quality or whatever, just being out first is rewarded. And it kind of sucks when it comes to detection things, because if the detection isn't like thorough and well tested and ultimately isn't that useful, it can give people and companies a false sense of security, thinking that they might be safe from the issue, and they're not. It's just they thought they were because the detection was not good. It can have like that kind of impact and amplify the issue and make it worse, which again, it's unfortunate, and you can understand why it happens, but it doesn't make it less of a problem.
Kind of tying on to that, when it's already out there and somebody's gone and put out, a bad piece of code or a bad template or like a bad detection, it's all like, yes, it on its own is a bad thing, but it also is going to mean if somebody's looking like, oh, somebody's already done this, I'm not going to bother looking at it. I'm not going to do it, or somebody who would have actually given it the appropriate attention to get it right may just
Mm-hmm.
not end up doing so and may not realize the problems that already exist. So yeah, I mean, having it out first, and then there's also that aspect. There's not much we can really say. Like, I doubt anybody who's trying to rush to put things out is also a listener of the podcast. Like, that does seem like a different type of professional,
Different
and who
crowd, yeah.
where a different crowd than maybe who we're going to reach with anything. But like, if that's you and you're just trying to get it out for the sake of getting it out, please don't. That's about all I could really say. Like, it's clearly not a good thing. It overall reduces security for everyone.
Yeah. Now, that said, as I mentioned at the beginning of the topic, there is also a bit of drama around this issue, and there's been some notable people in the Next.js community and just people in the Next.js community as a whole that are kind of downplaying this issue. So I did want to talk about that a little bit as well, because I do find it a little bit interesting. Now, I do want to preface with the fact that neither Z or I do a lot of like Next.js development. I just generally don't do a ton of web dev. But the whole premise around the downplaying here is basically people saying that Next.js's middleware shouldn't be classified as middleware. Basically, like in Next.js's case, that's not how it's typically used in their developer community, and that any auth checks or anything security sensitive shouldn't be done at that layer in Next.js. It should be being done at the page level or whatever. If your auth is exclusively in the middleware, then your project is wrong, is kind of the whole like thing around that. And I find that very interesting because there was actually documentation, and this has undergone a change recently because of this issue. Uh, so originally, Next.js's own documentation, like Vercel, had said that some common scenarios where middleware is particularly effective include authentication and authorization, as well as some other things like server-side redirects, path rewriting, etc. And that was since amended to just remove auth and authorization completely from that section and basically reword it to kind of shift the responsibility, I guess, and just say like, oh yeah, you shouldn't be doing auth here anymore. That was a documentation error. Instead of owning up to the fact that it seems like it was an implementation problem. So yeah, it's a very interesting thing. And I had talked to you a bit about this, C, because it ties in a lot with what we've talked about before with centralized security, right?
Yes, before we get there, though, I do want to touch on why Next.js middleware is a little bit different from traditional middleware, at least how the term's often used. So when it comes to middleware, the idea is that you're able to write your main code base. It does your application, whatever your business logic is, main application does that. And then you could just toss in a middleware, which I tend to think of it almost in the sense of like a proxy, where it sits in the middle of like your connection, in the middle of not necessarily your connection, but like the code flow. And
The
it can
front end,
tamper
like,
with it can tamper with the request data. It can tamper with the output. So it could be like, nope, we're denying this request, and like tamper with the output in that sense. It won't even pass it through. Or it can add things. So a common use case for middleware is just adding headers, like your course headers. You can do that middleware. And so you can write some code that is specific to this code is going to run. Specifically, it's going to deal with all the course header for the application. It's just this one bit of code on every request. It kind of gets called before it makes its way to the main application. It sits in the middle. That's usually how you think about middleware. The problem with, I guess, how Next.js does their middleware is that it's not only internal to the application. So usually when we talk about middleware, it is specifically this sort of, you're right, like it's all part of the same code base, and it's your middleware is just like another function, another class, another whatever being called into with the request. It's part of the code flow. Whereas the middlewares here can be completely new requests, like entire requests to a different server. Which in fairness, like I don't generally, that is like a different term than middleware. I don't know if there's a standardized term for that thing. As soon as you start making full requests like that, is, I guess sub request is probably a more common term. In something like Nginx, you've got a auth request that could be called, where it'll make a separate request, which can be like to a completely different server. And it'll make a request to that server, and depending on the response, it'll either like redirect over to an actual authentication place if it fails, or it'll let it actually go through. So like you could use it in that sense. Something like Caddy and Traffic, I think both call forward auth, which does the same thing. Basically, it's just sending the request over or sending a sub request over. So yeah, I guess like maybe a proper term for that would be sub request rather than middleware. So like there is this difference in concept in terms of how it works that is different, I think, than most use cases of middleware. And I think that nuance, like the fact that that's missing in a lot of the Next.js documentation, I think is kind of important. But when it comes to actually performing auth at this level, maybe there's something I'm missing specific to Next.js, but I don't think it's crazy to think of I want to do auth at the level of one, a middleware. Middleware auth, I think, makes perfect sense to do it there. And that comes what you were just saying with the centralization of security. Because middleware kind of lives outside of your specific requests, your developers don't need to remember on every endpoint, like, oh, I need to do this auth check here, and kind of doing it all ad hoc with every place it's needed. Instead, you write it in a middleware that's just like every request, every post needs this, every get needs this. Maybe you've got some pages that, your static requests or whatever don't need it. But and you maybe have some issues, some different issues when it comes to centralized, but when it's centralized, that means everything's passing through it. Or if something's skipping it, you've got a lot more insight into that versus needing to read every module or every function that might need it and like making sure it's always there. It does mean when it breaks for everything. That's kind of the downside, but it's a lot easier to apply universally when you kind of centralize your security like this. So I think putting it in a middleware makes sense. And even having it as a sub request, again, I think can make sense. Like I mentioned, Nginx has their the sub request auth thing. Caddy, Traffic both use forward auth. So like it's not an uncommon thing, and it's really the basis, I think, of a lot of like Google Cloud, I believe, provide like it's the basis of at least a number of zero trust systems where they'll wrap applications in their authentication, where the authentication is being performed by a separate server. And then it makes a sub request over to that. I know Google Cloud offers something with this. The term I'm coming up with right now is their Beyond Corp, but I believe that is what they call it internally, like what Google's actually doing. I'm not sure. So I guess I'm looking at this on a different screen. Might as well let the viewer see what I'm looking at too. Beyond Corp here, and they do have the pricing here. Of course, when you click pricing, it's just Google Cloud. Like it's not specific to that. I'm pretty sure there's another Google service that's actually a bit more specific for this sort of auth proxy setup. I don't know what it is offhand, but like that sort of system is like my whole point here is that sort of system is not uncommon. VPNs are also fairly common, but there is definitely a move to do this sort of zero trust system rather than like basically putting everything behind some form of authentication, and that would be using this sort of backend sub request to it. So like it's a very accepted solution is what I'll say. Now again, I don't know if there's something specific to Next.js implementation here that makes what they're doing different and problematic. So there definitely could be that. Like the way the sub request module in like Nginx or Caddy will work is the server is making that request initially, and then it'll redirect you if necessary. Depends on how you have things configured, but the actual request is being done by the server. It's not like being done by the client. So I don't know, maybe Next.js is having it done by the client. But yeah, it seems like Next.js did do some weird things, but also I see some talk on like, oh, middleware isn't the right place to do auth. That's something I largely disagree with. I would rather see auth being done in a very centralized way rather than needing to have developers, because there's always mistakes when a developer needs to do it every single place. It's just hard to remember as you're writing new code, like, oh, this thing needs this check, this one needs this check. Oh, but this check already happened here, so then we don't do it. And like there's just, it takes so much thought
It's kind
to
of been
get that
proven
right.
that method doesn't work. Yeah. Like
Yeah, it's like writing
We have
safe
a
code in
history
C.
suggesting it. Yeah. Yeah, you just can't trust developers to do it.
Yeah, and that
So
is not to shame developers in any way. It's just kind of like there's so much going on and it's so easy to make mistakes.
it's not a
Um,
reasonable expectation. Yeah.
yeah, and so by centralizing things, there is that. But yeah, again, haven't worked in Next.js, so I'm not wanting to come on here and be like, yeah, Next.js specifically, like, yeah, they're just wrong in that. But I did at least want to talk about the centralized security a little bit because I think it is an important movement to kind of understand the idea of centralized versus ad hoc security. And ad hoc security is just has been very problematic. And it's not like middleware stuff has never had issues, but middleware stuff is also a lot easier. One of the benefits of something like using a language like Rust is the fact that you call out code as being unsafe, and then it's like you inspect that unsafe code, and as long as that unsafe code doesn't make any bad assumptions or violate any assumptions, it should be safe. Similarly, when you have centralized security, it's like you can focus on that one set of code, not dozens of pieces of code all throughout the application that can all go wrong in their own ways. So there can still be issues. When it breaks, it tends to break worse. But on the whole, it also means you can patch it with like one place.
Yeah. So on that, part of what got me going into this rabbit hole is the person I mentioned earlier in our Discord had linked a video, and there was I'd watched through it. I'm just bringing it up just so that it's there for reference. But like one quote that was in there was, so this person Theo, they haven't seen any Next.js setups where they relied exclusively on the middleware for authorization. Is kind of a quote that was from there that stuck out to me, and I mean, yeah, I find that interesting, and that's kind of where a lot of the, you shouldn't be doing auth and middleware kind of came from as comments on that video, which some of them just seemed like pretty wild and kind
I
of funny
mean,
to
to
read.
say something like that is only in the middleware, so usually it needs to exist with something else. Middleware enforces or can be like, again, I'm using middleware in the more familiar sense and not Next.js sense necessarily, but can enforce the authentication, but you still need the wider like actual authentication system. Like you wouldn't implement the entire OAuth flow and callbacks through like middleware. You
No,
need
but
that still,
basically what
but
he was showing in the video to clarify was you should be like on the pages and stuff that have sensitive content. You should also be doing additional checks and like redirects away from there at the page level, not just at the middleware level.
see, yeah,
Um,
that is an approach I would disagree with because that is the ad hoc security where you need to remember every single page what is the security
yeah,
context versus dealing with it at a much more wide or centralized way. And I just went over all of that. That said, the approach of doing it on every page is still rather common. It's not like, oh, nobody's doing that. Like, people are doing both. I feel like the best practice is centralized. That is always what I've recommended for clients is doing things centralized. And that has been true for years. But the fact that I even need to say it is pointing to the fact that developers are very much not doing that in a lot of cases.
yeah,
But yeah, I have not
um,
watched the video, so I can't comment direct. I'm purely going off of what information you've
yeah.
provided me.
The only other thing I was going to bring up there from the video was just the fact, like, again, that fact that they don't think that it's common that this exploit would be useful, basically, that a lot of setups wouldn't be relying purely on the middleware for the auth, which I just thought was interesting. Maybe like I'm not in the Next.js ecosystem, so if that's true, that's kind of interesting that Next.js has this setup where middleware is kind of used differently, and that's just an accepted thing in that ecosystem, despite the documentation kind of refuting that. It's it's
Yeah,
weird, but
it would be surprising, especially, because I mentioned even if you're not using it for full authentication, things like cores are often implemented through middleware because it's very easy to do it there rather than like trying to implement the right course header on absolutely every page. It's like, because there's a lot of overlap. Course headers like generally are they're not static across the pages, but like you have a lot of overlap across your pages in terms of how you're going to handle it. So you do that in a middleware too. And so that could just be a security issue beyond just the auth bypass. Because the thing is, this bug did allow you to bypass middleware, not auth specifically.
Not auth specifically, yeah.
Yeah, like there's a lot of potential impact for middleware being bypassed in terms of adding or removing headers. So that would be the cores example. Auth, session management. That was something I think in the commit.
Yeah, there was something that was removed from the commit. They put session management under middleware not being a good fit for.
Yeah, and that is something that I've seen middleware used for. And again, when it's in the code base, if this is running like a sub request style, you wouldn't want to like fetch your session. That like that totally makes sense. They call it out with slow data fetching. I get that, especially with how it works. But yeah, making it clear how it's different from normal middleware probably could have helped, although I'm not sure, I guess.
Yeah, I mean, so it's interesting, like clarifying the documentation and trying to shift away from what they had before, but it does feel like a massive cop out. I will say that it seems like it's something where you don't want to acknowledge that like the middleware should be secured to be able to do those things, and instead you're just like you just shouldn't use it like that. Just do something else. The developers are wrong. Like,
yeah, because
that's what it feels like.
Like they've dropped a lot of functionality here because they have some common scenarios where middleware is effective, and then prior to this change, they had the auth server side redirects, path rewriting for like A/B testing or feature rollouts, feature flagging, logging, analytics, again running in the middle, so you could just track things with all the requests without needing to write it into all of the pages. And they've just removed, like, all of those are things they've removed versus just quick redirects after reading parts of incoming requests, rewriting to different pages. Like, they've basically removed a lot of things that middleware would generally be used for, which could be related to how this middleware is different and how it operates differently. And I have not played around with Next.js enough to comment on that. I just understand that it's using more of a sub request system. I'm not sure. The way I'm reading this now is making me think I initially thought it was still Next.js making that sub request, but if it's actually using the client to make the sub request, that does definitely change the threat model of these requests. It does feel very different than even anything you'd call middleware. So yeah, I don't know, because they do, but because they've removed the server side redirects, which would be a case for middleware. Like traditional middleware would do server side redirects, like absolutely. And the fact they removed that now gives me pause about my understanding on that. And yeah, it almost feels like whatever they're doing maybe shouldn't be called middleware if it's not able to do these things. But
it is still fair to call out, like, yeah, their documentation was a bit misleading, and the way they use middleware, like, there was a comment on the video that I kind of resonated with, and that's that if Next.js uses middleware in a completely different way than the rest of the industry, then that's on them. No reasonable dev would expect this to be the case. And again, like, that's something we've talked about before with, like, there should be that level. Yeah, the law of non-surprise. I was trying to think of the term. I couldn't think of it. Yeah, exactly. That is something that is important to consider. Even if it is a bit weird in Next.js's case, and a lot of Next.js devs are aware of that, that's still, like, not a good thing.
Like, yeah, I don't think it's fair. And to be fair,
the video kind of says that too.
Yeah, I don't think it's fair to expect developers to read the docs. Sometimes it's true. Like, we get this is a thing with PHP a lot, where it's like, it's documented that it's a security problem. In this case, it wasn't even documented, but PHP kind of has that history, and so there's a lot of these foot guns that are just documented. It's like, well, you should have read the docs. People don't read the docs. They would rather spend 5 hours testing than 5 minutes reading docs.
Yeah.
And whether or not they should, because part of the problem is docs get outdated. People don't update it. There are problems with maintaining documentation, where sometimes reading the docs can be worse than just having played around with it to make it work how you want, because the docs are just wrong. And so, developers have kind of created that situation themselves by not wanting to do their own documentation. And so, like, you can't necessarily trust, but also names mean something. So if their middleware is operating very differently from how the rest of the industry would consider it to be middleware, that is, the law of non-surprise. Like, it's violating that easily for using a term without actually doing so in accordance with how it's generally used. It's just kind of, it's pointing to other issues, like more systemic issues with Next.js. But yeah, I mean, when it comes to reading docs, I just don't think it's fair to think developers need to read the documentation for absolutely everything, because if you're using libraries, part of it's there to speed things up. You shouldn't need to understand how everything's implemented in order to use like the library or the framework or whatever. Now, don't get me wrong, there's benefits to understanding your tools, and like obviously you want to learn and do all of that, but you still can't expect that for everything somebody's going to use. That they're going to dig into absolutely every aspect of it and all the docs. That is a lot to ask for somebody, especially when they're reusing common terminology. It's the overloading of terms. It would be great if everybody did read all the docs. It could probably make things better, but I think ultimately you just need to make the code more resilient. That is actually one thing I like with some framework stuff. They've moved to using much more clear function names where they'll indicate like safe or unsafe functions, or like dangerous something. And things like that, to make it very clear when there's some like important edge case. That at least developers might not read the docs, but they'll read the function name. I don't know about you when you're dealing with like a new code base, or like library or whatever, but I often, I'll have the IDE will autofill and show me like, oh yeah, this thing has like these methods or something, or there are these functions or whatever. And I'll use that to figure out things, and maybe I'll read docs from there a little bit, but I'll use function names a lot. So when they start including information about safety in that kind of improves the situation. Now, I don't know how you do that with the middleware thing here. Like, there isn't a clear way of just rewriting it. I think it is just, the proper terminology, but it sounds like there's some weird architectural stuff going on here that I also just don't understand.
Yeah, so it's something I kind of wanted to bring up because it is something we didn't get into when we covered this topic initially, and there is a lot of interesting perspectives on it. I don't think a lot of the people talking here and like the video that I mentioned, like I don't think anyone's really wrong. I saw a lot of comments that were attacking the video itself and saying like, this is shielding Vercel where it shouldn't be and all that. And like, I think the video has valid points, and that ultimately it is kind of that terminology issue there. And yeah, it's one of those things where it's just kind of an unfortunate reality. There's bound to be misunderstandings. That's just the way it is. But yeah, like what we were talking about, the centralization of security, like that is still, something that is a fun discussion to get into. And it seems like there's a bit of a clash still between security researchers and developers on that kind of philosophy.
Maybe. Oh no, it does seem like Next.js is a bit different in terms of the middleware, and even the guy in this video might not disagree with using middleware generally for that, but not with Next.js.
Yeah.
I don't know for sure, but
yeah, we'll move on to some of our other topics. So we also have a post from LandH here, and this is also something we briefly talked about in the last episode, and that's on hacking some Gemini source code. So it involves research from Lupin and ResZero and Ryan Nader from Critical Thinking, if you're familiar with the Critical Thinking podcast. And while it does involve a little bit of stuff involving prompting, it has more to do with sandbox Python and files sort of accidentally making their way into the sandbox that shouldn't have been there. So this research came out of an event ran by Google, LLM Bug Swat. I believe we talked about it a little bit when these events started, but it allows researchers to hack on, in this case, a preview build of the newer Gemini version at the time, which is Gemini is Google's AI. And they discovered that Gemini supported the ability to generate Python code and actually let you run some of that code inside of a sandbox. You know, the code embed would have a little run button to be able to do stuff. That sandboxing was enforced by GVisor, which is a Google thing that seems to be pretty solid. They mentioned in the article that they haven't seen anybody be able to escape it, and escaping GVisor could yield a 100K bounty. So escaping GVisor isn't really what they did here, but what they did do was they crawled the file system using Python to explore the sandbox, and they found this interesting entry point binary, which they were able to exfil. There were a bit of challenges with that due to, like, you know, file sizes and whatnot. They ultimately were able to extract it piecemeal by like base64 and you know, chunks or whatever. So they were able to extract that. They could run it through binwalk. And they were able to find all these files, including internal scripts and code for Gemini to do RPC calls into other Google services. So that was pretty interesting. But in itself, that wasn't a vulnerability. They brought it up with the Google researchers that were there, and they reviewed it. And it turned out that the inclusion of that code in the sandbox was deliberate. Google effectively considered that code public. But it was pretty cool because they were able to send and receive RPC messages directly to these Google tools. And those messages were serialized with protobuf. If you haven't used protobuf before, it's a powerful serialization format, which is really useful because you can encode a lot of different types of data. You know, you can have integers, binary, blobs, strings, whatever. It's similar to JSON, but you can support a lot more things. And it's not a plain text format, but there's a lot of libraries and whatnot that are built for different languages to interop with it, especially when you have things like Google's gRPC, which you can use on top of it, where you can auto-generate wrappers for different languages for handling protobuf data. So,
I mean,
yeah,
sorry, the code gen stuff is actually part of protobuf. Like, that is in gRPC. Like, you can do gRPC for actually having the
for
calls and having like even
yeah.
more handling around it, but just even being able to take the input stuff, that is like protobuf core.
That is protobuf.
Code gen, yeah. Which makes it really nice because you write this protobuf def and you can use it in like whatever language you want to consume the protobuf in.
Yeah. A lot of proto files for Google services here are supposed to be private. They're not intended to be public. But it turns out that in some instances, it's possible to leak paths and snippets of internal protos if you could get yourself into a bit more of a privileged sandbox. And by that, what I mean is, it seems that there's sort of two different scenarios you can end up in with sandbox. And that depends on how the code is ran. The way I understand it is, if you try to run just arbitrary code directly inside of the sandbox, you're in a bit more of a restricted sandbox where it's not, you can't talk to Google services. It's not supposed to have that capability. But if you can get Gemini to do something where it needs to generate code to do something itself, the example they give there is you ask it what's the earliest flight between two airports. Well, then it's going to generate some Python code and interact with Google Flights, and it's going to send requests over that and have that RPC. And in that case, the sandbox is a little bit different because the sensitive proto files that are used to communicate with those Google services could end up being included in the sandbox unintentionally via the build pipeline, because they state that the build pipeline had an automated step that could add security proto files to the binary if it detects that it might need them to enforce some internal rules. So that binary that they could exfil in some cases could include those sensitive protos. They don't go that much further into it and don't show the protos they were able to leak for legal reasons, but yeah, it is a pretty interesting chain. I was saying to Z a little bit before the show, I've never really considered proto files, like for the structure of the data to be sensitive. That said, I haven't really, used protobufs in like enterprise setups, and I could kind of see why you would want the API and the data structure and everything to be, not public. to be undocumented. So in
Yeah, I
that
could.
context, I could totally see why this would be an issue. But yeah, it's an attack that I didn't really think of, but it's very cool.
I could see a couple things going on here in terms of the value of leaking the proto. So one is, yeah, just internal API. So yeah, Google does publish protos for like their public APIs, so leaking those is not going to matter. Internal APIs, yeah, it's just like, disclosing, the fields and all that of an internal API can just be valuable information to some attacker in some way. We talked about a bug not super long ago where was a leak of a proto. It wasn't a proto file, but they had another way of leaking proto information that then reveal like, oh, there's this field that then let them ultimately leak YouTube emails, I think it was. So like there's that sense where there could just be sensitive information there. And then it seems like specifically on this one, they call out searching for the string dog food or dog fooding, if you're familiar with the term, which is just the idea, well, the general idea of dog fooding is the idea of using your own tools internally. And so it sounds like this is also like they had pre-release versions of products and prototypes that were being used internally that could be included in here. And then the thing that they kind of call out or kind of focus on is that one of the exposed files here, this privacy data governance attributes proto classification of proto, which details how Google internally will classify different user data. So like it is kind of revealing a lot of the internal security details. I guess we obviously can't see it, so I can't be like, yeah, it's doing this. But they kind of call it out as it doesn't contain user data itself, but those files are internal categories Google uses to classify the user data. So it's kind of revealing the categories it works on, I guess, which again could be useful in an attack. But yeah, it is a interesting thing. Like it's not something I would traditionally think of as being really sensitive, but I could also understand why in this particular case, internal product, pre-release products, why that could be considered kind of important to try and protect.
Yeah. And ultimately, what matters there is that Google treats them as highly confidential. So that's ultimately what matters there. But yeah, like I think we've covered some research that has come out of these bug squad events before, and they're always very interesting to follow. And another thing that we had talked about a little bit before was the fact that these events are ultimately very cool, and you're kind of guaranteed to have some good research come out of them because you were able to have that back and forth with Google developers that are on site. And you can kind of ask them, like, hey, is this route worth pursuing? Is this something that you would consider as violating your security model? It saves you from wasting a lot of time on dead ends, and it allows you to be a lot more efficient with your research. So
Yeah,
yeah,
so
these events are really cool.
this isn't specific to Google, so it's live hacking events in general.
In
Live hacking
general, yeah.
events like HackerOne. I think all of the programs run some form of this, where they get people together to hack on one or like a set of targets, and they have developers available. And yeah, that developer acts. So one of the things I do appreciate, and I like to call this out when authors do this, is they do include some of the points where it's like, I think one of the notes here was like, yeah, this actually took, note from Lupin. In the article, it seems like a straightforward path, but this actually took several hours to get to this point. It's 3 a.m. and we're sleeping at the keyboard and all that. Like, I appreciate those details because it is often you read these things and everything kind of fits together in hindsight. Everything always, like, the puzzle pieces always fall together in hindsight. So then you explain that, and I think a lot of people reading this then get the feeling that the puzzle pieces fit together and they just knew everything right up front on exactly how it all fit together, and that's usually not actually true. So yeah, they include a few comments like that, and one of the things they do kind of call out is being able to ask the security team from Google, like, hey, we have this sort of, they won't use, I don't think they use the term primitive, but like, we have this sort of primitive. What could we do with this? And the developer is going to have a lot more insight. Oh, like that thing could access this or do this or whatever, and kind of give some ideas on what might be available if you could do that. And so just speeds up a lot of the kind of attack, or well, the research time, really. Yeah, obviously the live hacking events do that if you're a pen tester. I've definitely been on engagements where, flowing over to be in an office with the actual developers or with the security team or whatever. And, being able to bounce those questions off is a massive time saver when it comes to how you allocate your time. So just like, you have something, you can spend a dozen hours trying to figure it out and see if you can do anything with it. Or you can ask somebody who already knows, and they could be like, yeah, no, this, like, we do this, this, and this. Therefore, you only get this. So, assuming best case scenario, you get, like, nothing. Or actually, yeah, there's this thing you wouldn't have even known about except for, like, another 10 hours of research. Or they tell you immediately. So, yeah, it really improves the hunting and lets people find some of these cooler bugs. And I do think this is still a pretty cool bug. The impact is, like, ultimately, it kind of comes down to a pretty simple thing. One is just being able to read files via Python, and then just the inclusion of sensitive files. Like, it's kind of simple, but it's also kind of a cool bug. I don't know. It's in some weird spot.
Yeah, it's not a generic chain. It's kind of abusing some specifics with how their sandboxing is being done. And as you mentioned the last time when we had this as a shout out in the last episode, doing sandboxing when it comes to things like Python and whatnot is just difficult. You have so many things you have to consider. And that case where these things ended up in there because of the build pipeline, again, that's something that's kind of hard to anticipate. You have to kind of discover that the way that it was discovered here. I don't think you'd be able to just look at the build scripts and whatnot and just like automatically assume that this is something that could be an issue.
So,
Especially when you have LLMs and you have differences, because they mentioned that they had to do some architecting with the prompts to get this scenario to work. You wouldn't always end up in the scenario where these files would be included. So because you have that like randomness or differences between different prompts, that also can make it more difficult to, detect things like that.
yeah,
Those
when
kinds
you
of
call
issues.
out, like, not doing it from the build scripts, I agree and disagree. I think now that it has been pointed out as, like, oh, this is a concern, I think it is something they could probably do at the build level and be like, yeah, like, these get filtered or something.
Going forward, yeah.
Yeah, like, it's really easy in hindsight, too. And Google seems like the type of company that would implement a process to prevent this sort of leak where possible. Of course, it was including these protos because it needed them or potentially would need them.
Or it
Uh,
thought it needed them at least, yeah.
yeah. So there is that aspect, but like, yeah, now that's pointed out, it does feel like a thing that can be fixed with a process update. So in that sense, like, it could be, it's just you wouldn't necessarily recognize it as an issue initially, which I think is
Yeah.
also kind of aligned with your point. I enjoyed
Yeah.
this read. You mentioned the Python sandbox stuff. Like, that used to be such like a classic CTF challenge too, to just escape the whatever Python sandbox. Like, I've done a bunch of CTF challenges that were like just different sandboxes stuff. So this wasn't really an escape of it. They lived inside of it and found their way inside of it. Or I don't know what I'm trying to say with that, but they just found sensitive information inside the sandbox.
Yeah. And it's a little bit interesting where it has the LLM context here too. We've talked before about the fact that as you add more features and functionalities to LLMs, like it's just your attack surface goes up by so much. And when you have the ability for the LLM to communicate with different things, different APIs and RPC and everything, like it's yet another thing that you have to lock down. So it's good that there's some research being done on that. And
Yeah,
yeah,
and I
like you
could
said, it was a
imagine.
very enjoyable post to read through as well.
Yeah, in the future, I could imagine like there also being more research on specific function. So I'm going to use the term function call here. There might be a better term now, but I think of like OpenAI introducing function calling as being like the structured calling method for like, yeah, call this function. But yeah, I could imagine in the future we'll also see more research that just focuses on like this function has this sort of vulnerability that could be misused by like AI calling into it incorrectly or something. We haven't really seen that yet, but it feels like when we're talking about the increased complexity, and I think something we'll actually get to in a shout out, but also with some of the changes in terms of being able to share and reuse some of those functions, we'll probably start seeing research that just focus on like this function has an issue and, however it's being used in AI isn't really the focus.
Yeah. And on the subject of APIs, that kind of segues nicely into our next post. So this was a post on Verachains.io, and the title of the post is Technical Analysis, Improper Use of Private iOS APIs in Some Vietnamese Banking Apps. And yeah, so this touches on a bit of an interesting case where this wasn't a bug that was reported directly by a bug bounty researcher or a bug that was used in the wild to attack an individual from like an APT or something, but it's one of those cases where a company is using a bug or an undocumented behavior for their own advantage. So this talks about a case where some Vietnamese banks, particularly BIDV, Smart Banking, and Agribank, used a private API on iOS called SPS launch application with identifier and URL with launch options. Bit of a mouthful there. But they basically were able to use this API to try and detect and side channel if certain applications were installed on the device. In this particular situation, the banks were using it to check for the presence of troll store, which is something that allows you to sideload applications and abuses a bug in Apple mobile file integrity to allow you to sideload those applications. So where it's used in iOS hacking, you can kind of understand why they would want to detect the presence of it and, you know, block functionality in the app. The problem there, though, is that this API ultimately is undocumented and it is effectively a sandbox escape. And the article mentions that apps using private APIs to enumerate installed apps violates the App Store's policies. So it isn't something that Apple likes apps doing. And it seems the banks were somewhat aware of this because they obfuscated their use of this API. It was pretty weak obfuscation. It was just like a weak XOR scheme, the kind of thing you would typically see in like CTFs or something. But they did go out of their way to try to obfuscate usage of that API.
I kind of want to, in a sense, criticize the article on that statement. XOR is perfectly sufficient for this use case. It's a little bit like in malware. This is going way back, but I have no idea what like the modern trend would be for this. But to get around an antivirus, people would use just like a 1 or 2 byte XOR key across the binary and kind of just decrypt it at runtime. And that's sufficient for the use case when all the antivirus of the time was doing was looking for the sequence of bytes. XOR will simply change the byte sequence when you apply it like that. Like, it's exactly what you need. It's very quick. It's very easy. Like, you don't need to use like AES or something to encrypt the strings because you're decrypting them anyhow. It's going to be in memory when you need it. And so calling it like, oh, it's a very weak XOR, like, it's exactly what they need in this case. They're trying to avoid the byte string. It is surprising that Apple wouldn't have because it doesn't sound like they did anything to prevent calling this like while being scanned or something, or at least it's not mentioned. If they did, that might be a difference here, but it sounds like Apple's only scan was they looked for the strings. And if the strings were present, in which case using XOR is just fine. Like, they don't need AES security. They don't need strong security to prevent like somebody from brute forcing it. They just need to change the byte sequence. It is completely fine to do this. Like, this is not, it's obfuscation, not security. And like, in fairness, like, I don't know, I just, when they say it's a very weak like, I don't know, it rubs me the wrong way because it seems like they misunderstand the point of this. Because the point is not to prevent anybody from knowing about the string. It's just to get around the fact that Apple's scanning for it. Which, again, surprises me that that's all that's needed. Like I said, this is a technique that was used by malware 20 years ago. Like, it's not exactly something that should have been thought about. Like, I'm genuinely surprised that Apple wouldn't have just a runtime scan for are these APIs called. Although maybe that's too noisy because if it's used internally, like, yeah, I guess I could maybe see some issues with that. But oh no, it surprised me on how trivially they were able to get around that. But they do have to scan a lot of apps, though at the same time they also have to pay them for the privilege. So I'd expect better.
Fair enough. Yeah, so I'm kind of curious, do you have any like thoughts or opinions on because like this behavior of bank apps and these like sensitive apps trying to detect jailbreaks is very common. You see it in like WhatsApp and like those kinds of communication apps as well. Do you think that that's like something that maybe should be supported by Apple? Like, do you kind of support that use case, or do you think it's too much, like it's over the line?
I don't know. I'm of two minds on it. From a security perspective, I understand the thought. Um, but at the same time, if you've like these sort of detections aren't really ever going to be sufficient because Apple locks their devices down so you can't actually do the sufficient checks. And so I don't really feel like the apps should be trying to do it until Apple were to actually provide proper mechanisms for it.
Which they probably will never do because Apple has a lot of their brand built on privacy and apps being able to detect what other apps are installed is kind of a big thing privacy wise. In
That's
the
the
in the
other
case of a
thing.
bank, like you can kind of understand the use case, but then do you have a special entitlement that you only give to banks? That's kind of weird. Like,
Well,
yeah,
special entitlement to security applications that can, be enabled optionally. Like that's kind of a key thing. I don't like the idea that applications, banks, security or otherwise, try to require users not use their devices how they want to use them. Um like that it's like of course I'm in support of like jailbreaking your devices and all of that. I feel like that's kind of a natural position to hold. Like, should be you bought the device, should be able to do whatever you want with that device. And so I'm not a fan of the banks trying to be like, no, we don't want you to having done this. Now, I get it in the sense of I want to protect my users in case they have malware installed or something, which is why I'd kind of said like, maybe something that's somehow optional for users to like opt out of that. But then could the malware then just like say, yeah, I'm totally the user trying to opt out of like the security or whatever. So yeah, I don't know on that front. Like I get it, and like phones are genuinely more secure because they are limited because of the limitations that are being put on by Apple, by Android. There's genuine security that has been gained from that compared to like your desktop computer or laptop or whatever. There is a genuine degree of security that's come from that. I do think there should be some mechanism, not for all apps to be able to do it. Some type of API, like something should exist for those that do have the higher security needs. But I am mostly thinking more of the threat model of my phone might be attacked and like needing it that way, not the bank trying to prevent people from having a jailbroken device. Because I think more likely what they tend to catch with this is not people who have had their phone compromised, but people who have jailbroken it themselves. And then it's just like, nope, we don't want to let you do this anymore. And that I disagree with.
yeah, that's kind of like I remember this argument from years ago about stuff that Apple was doing, trying to mitigate jailbreaks and things like that, and that uh people were annoyed because there's all this effort going into preventing people from jailbreaking their own device or using functionality if they jailbroke their own device. But meanwhile, actual spyware, like these mitigations aren't doing anything about because, spyware is not going to be going through like Troll Store or something to, uh,
Yeah. Like that's the
like,
thing. It doesn't exist against or it doesn't do anything and offers no way to get any protection against real malware. Like
yeah.
it does at like a very basic level, but not the stuff that actually is concerning.
Yeah, it seems more about the application trying to protect itself than trying to protect the users. So, yeah, I mean, it is fairly common, and this certainly isn't the first instance of a side channel like this being used. But yeah, this is like the latest case that's been documented, and it is a little bit interesting. I was under the impression that these kinds of private APIs, like you said, I thought Apple would have a bit of a better protection against it
Yeah, I just
being abused.
assumed they would have had some sort of runtime check on like, oh, this is being called like, or this has been called unexpectedly while they're like ran the test device, like ran the test or whatever. I just
Yeah,
assumed they had something like that, not XOR it. You're fine.
and you're good. Yeah.
Yeah.
I wonder if that will change. Apple has been known to kind of adapt to what's been shown out there and strengthened. So I could see that changing. But yeah, in this case, it was that easy. So
Yeah. It's not really a bug per se, but it's still just an interesting technique, I guess. I don't know. I mean, XORing a string isn't even that interesting of a technique. Like, oh,
yeah.
fascinating. It's XOR. Like, of
Yeah, no,
course
for
it
me,
is.
the thing with the undocumented API aspect of it was definitely the more interesting thing. So our next post here is by Microsoft, and this is about protecting linear address translations with hypervisor-enforced page translation, or HVPT. And so this is a newer mitigation that has come to Windows 11 and Windows Server. As the name suggests, it leverages the hypervisor and existing virtualization-based security within Hyper-V to protect guest page tables against things like remapping attacks. So the whole thing with paging, so for those not super familiar with paging, you have virtual addresses and physical addresses. You need something that facilitates that translation. Virtual memory is really useful for isolating between different apps and whatnot. And the way that that all kind of works is virtual addresses will sections of the address are used to index into a page table, and page table is used to connect virtual addresses to physical ones. And so because pretty much everything that's running on the computer for the most part will be using virtual addresses, one very useful technique for attackers to go after is attacking those page tables, whether that be to insert new entries to map some memory that they want access to, or remapping existing things so that the application is like looking at an area of memory, and you suddenly swap that as an attacker to point to some other memory that you control or something. That can be very nice for like switching out code pages. You can do things like that to get around some of the existing hypervisor protections. So for example, like hypervisor code integrity will try to make it so that you can never gain write access over code pages in the kernel, and you can't allocate new executable pages. But one way you could kind of get around that and do some interesting things is just remap those pages so that they point to different code, so that when it goes to jump to some function or whatever, it's executing something that it's not supposed to be. And you could kind of use that to violate assumptions. So attacking the page tables has been a weakness that has been thought about and exploited for a while. So protecting those page tables from being modified by attackers is something that there's been a lot of effort into lately, and Microsoft is kind of coming to that now. There has been some other like companies and solutions that have already been doing this for a while. One that comes to mind, Samsung with their real-time kernel protection. This is one of the things they do. They try to protect the page tables so that you can't just unmap and remap memory to attack the host operating system. It
And
tries to protect that.
one
Sorry,
of
go ahead.
the one of the things I kind of want to shout out here is also that attacking the page table is just attacking data that exists. Generally, the kernel is managing the page table. Well, it's a little bit more complex with hypervisor
Which is what we're going to
involvement.
get into. Yeah.
But it's data focused. Like you're not needing to. You could do attacks here without actually violating code flow, which is big part of mitigations in the last 5 years have been code flow mitigations. Intel CET, CFG, all those things are there. Do that. They like do nothing against these data oriented attacks against just the page table data. So that's also why like there's been a movement in exploitation towards the data sitting there too.
Yeah, 100%. Like because of the advent of CFI and CET and things like that, which we also have another topic kind of touching on. Going for those data only attacks is a lot where a lot of like the exploitation meta has shifted towards, and page tables are just such a juicy target. They offer so much capability if you can modify them. So yeah, like you had mentioned, the shift to trying to protect the page tables has been leveraging virtualization. So the way that Microsoft is doing it here, and this is the way that it works in a lot of cases, is they leverage the ability to run a secure kernel. So you have your normal world kernel, like your typical Windows that you're familiar with. You can call into with Win32 and whatever. But you also have a secure kernel, and that's being isolated off into this other world. So you have VTL0, which is running the regular kernel, and VTL1, which is running the secure kernel. And anything sensitive that the normal world needs to do. So, for example, in this case, that would be modifying or inserting page table entries. Instead of doing that directly itself, it's going to make a call into the secure kernel and ask it to do it. And by doing that, you can make it so that the normal world that you would consider insecure or potentially compromised only has a read-only view into the page tables. So, it needs to be able to read them, it needs to be able to use them, but any modifications would have to go through the secure kernel, which you would consider trusted. And so because of that, you can establish an API and set up gateways so that you can't just do whatever you want as an attacker over the page table. Maybe you can do some stuff if you can leverage that API. But again, kind of calling back to what you were talking about, then you're also requiring an additional capability on the attacker side, because it's no longer just a data only attack. If you have to use hypercalls and go across that boundary, well, then you're going to need code execution, which has a little bit more mitigation set up around it. That said, going from a data attack like arbitrary read write to code execution generally isn't super difficult, even in the presence of CFI and things like that. But still, it is an additional step that's required. So yeah, it's a strong step that's being taken. It generally has proven to be fairly effective at preventing page table based attacks. And yeah, it's cool to see from Microsoft. It is a bit of a short post. It just kind of goes into an overview of how it works. And it is just part of a general shift that Microsoft seems to be making, where they're starting to move some of these more sensitive, low-level things away from the untrusted kernel and into the secure kernel, and establishing an API for that. And, it's obviously a smart thing to do, because it's kind of been proven over the years that you can't trust the host kernel. It's too easy to compromise.
And I mean, they now have a layer with Windows 11 largely, where they can start trying to have more trust. Not more trust like the
they have
kernel,
a better chain of trust.
Yeah, like they have a better system in place for that. That said, are we sure this is actually happening? Because I do notice that this is an April Fool's post. So, maybe we've been fooled.
Yeah. No, this is an actual thing. I did do a bit of looking into it.
Yeah, okay.
I believe it's actually landed already on like at least the preview builds, if not some of the stable builds. But yeah, so it is a very strong move. And like you said, that is something that I think is maybe important to touch on too, is part of why it's taken so long to get to this point is, for a long time, the chain of trust was a bit of a joke. The kernel, like if you're an attacker who's looking to subvert the hypervisor and everything, or well, even before the hypervisor, like you could just gain access at an early point in the boot and just compromise everything thereafter. But now, because of things like TPMs, being able to have secure measurements and having root of trust inside of secure elements like the Intel ME or the AMD PSP or whatever it is, you're able to provide a lot stronger of security guarantees on the boot process. And because of that, that's what allows you to boot into this system where you have the hypervisor that's running at a high level and it's able to isolate the normal and secure world. And it allows these types of protections to be a lot more effective than they would have been in the past. So it's a bit of a culmination of different technologies coming together that allows this to work. But yeah, I mean, leveraging the hypervisor to protect page tables and other types of tables. Another thing, for example, is like, this is particularly interesting when you get to things like anti-cheat and cheat developers that are using DMA attacks. If you can move a lot of like the IOMMU stuff and like just memory mapped IO in general behind the hypervisor instead of just having it in the guest kernel, you may encounter a bit of a performance penalty. I'm not sure exactly how much that, like what exactly that would look like and what you could feasibly move over without it being a problem. But the more of that you can move over behind the secure kernel, the better overall for the security of the system. Now you do end up in a trade-off, because the more you move behind the secure kernel, obviously you're adding more attack surface. You have to design APIs to facilitate updates and things that are needed for the host OS to function. You are adding more code into the secure kernel, which generally more code equals more bugs. But that said, ultimately it is, I think, worth gating it off instead of just letting the untrusted operating system be able to do whatever it wants. So it's cool to see from Microsoft, and I expect we'll probably see more things get moved behind the secure kernel and into the whole, virtualization based security model. That'll probably only get stronger as time goes on. So
Definitely. Yeah, it's definitely the trend where they're pushing things. I mean, really with Windows 11 pushing like everybody having the security module on, well, I mean,
the
technically you can
TPM,
get
yeah.
yeah, like technically you can get around having that, but like by default it pushes you need that. Then pushing on that, so having the chain of trust and then having the hypervisor available, because for a while their Hyper-V was only available, and even the virtualization based security was only available on Windows Pro. Now it is available more generally. I mean, you can't use the hypervisor if you're not on Pro, like you can't do your own stuff with it, but it is still available to run like the more secured kernel and all of that.
Yeah, it's something that Microsoft's working on, and it's good that, one of the things that's always been said with Windows and Microsoft is, because of the legacy, there's whole philosophy with always wanting to support old devices, like the security has lacked behind a lot of other stuff. And it seems like with the work they've been doing with virtualization based security and with secure boot, it seems like they are catching up in a lot of respects on that angle, at least. Maybe not so much the user mode and kernel side of things, but beyond that, at least, it seems like they're making quite a bit of headway. So that's
Yeah,
cool to
and I
see.
could, like, this, obviously is going to have some implications for the more user mode security too. Just in general, the virtualization based security, because they're not going to make the same mistake, I think, of letting vendors create drivers that are going to run at that same security level and stuff. Like, I
Yeah,
doubt
it
they're going to
seems
make
like there
that.
is a lot of effort to try to mitigate the damage that vendors can do
Yeah.
with the code they stick in. Um, yeah, I totally agree. And kind of in the same avenue of that, there was a post that you found interesting, and that was this post on Slowers' blog on code reuse in the age of kCET and HVCI. So kCET, they're talking about Intel's control enforcement technology, which has both forward edge and backward edge protection on for control flow integrity. And yeah, so HVCI is mentioned directly there. The combination of uh, control flow integrity and hypervisor enforced code integrity is a pretty powerful combination, and is very nice to have. That said, there are some ways that it could be gotten around, and that's kind of what this blog post gets into, right?
Yeah, that's fundamentally what they get into, is basically just pointing out kind of the not necessarily overlook thing, because we've called this out as kind of like, the back door that still exists through all of this, through all the mitigations being introduced. But yeah, it gets into, what you can still do, namely jump. They kind of have a big focus on jump oriented programming, basically CET. And core thing there with shadow stack being enforceable is puts a very significant damper on being able to do any sort of return oriented programming. And that's just because it protects the stack from being corrupted. There are some attacks that have existed against shadow stack and all of that, but generally speaking, it is a good security mechanism that protects the stack. Uh, so you can't just like write your ROP chain and start returning and having go. But JOP operates on jump calls. It's jumping to its different gadgets, jumping between its gadgets, which means instead of being backwards edge or on the return, it's forward edge. And forward edge is generally less protected. There are some things there, but it is not as secure. And so that's basically what they get into, is trying to build up a JOP chain. And one of the things I thought was kind of interesting was how they found their JOP gadgets. And that was through symbolic execution. Effectively going until um give me a moment here to find the quote I'm thinking of. Right. So this first kind of a couple sentences, they wrote a quick script, list all val call targets, and then basically looked at those, ran symbolic execution on them to see when the instruction pointer could no longer be solved by symbolic execution, which is basically telling you, okay, the pointer at this point is no longer constrained to just some small set of values. Is something has happened that has opened it up such that it cannot be solved. It cannot say what the pointer will be. And yeah, I mean, I haven't made a very heavy use of symbolic execution, but like when they point it out like this, like that makes good sense as a way. Like it's not the approach that I would take for like finding job gadgets. Um, but it sounds like it's relatively effective, like especially when you're dealing with it in combined with uh the mitigations in play. So yeah, I thought that was just it was I just thought it was an interesting approach. As opposed, this is I think just more of a shout out than anything. There's no vulnerability here. It's just yeah, you can still basically go and do like a job chain. They talk about some of the difficulties there. Talk a little bit about job. This maybe won't be my recommendation if you're unfamiliar with a job completely. A little bit of the challenge with like finding a dispatcher gadget and all that sort of deal. I thought the symbolic execution use there was an interesting insight. But that's the main thing I kind of want to call out from this. If you're unfamiliar with JOP, then you know it could also be an interesting read just about the challenges they faced with it and getting it off. Yeah, I don't know. I don't know if you had anything else out of this, but that was kind of my take with. I'm just like, hey, that's a good idea. I like that.
Yeah,
Game.
so it's kind of cool how it doesn't really call it out explicitly, but it gets around some of the weaknesses, or it abuses some of the weaknesses that are present with CET and control flow integrity in general. And that's the fact that, you know, you're going to have some valid call targets ultimately. And if you can get a valid jump target that is also a valid job gadget, well, then you can kind of just spiral from there, because they call out the fact that CFI and whatnot, it only protects that initial jump. You have to rely on the code checks being there to enforce that code integrity. So if you can get around that first jump, then you can just kind of keep going, and you don't have to worry about it anymore as an attacker. So that was kind of an interesting point. But yeah, like you said, it was neat seeing the symbolic execution there. Prior to this, the only places I really remember seeing much about symbolic execution and it being used was in like the white papers that we used to cover.
In fuzzing. See it along fuzzing world. Yeah, fuzzing white papers are same for me. That's really where I thought of symbolic execution being used. I've seen it a handful of times in CTFs.
Yeah.
Never my choice. It was never like I was doing this. It was always like I saw somebody, you know, solve it with like maybe some symbolic execution or something. Yeah, no, this was the first time I think that I'm seeing it being used in terms of just exploit dev is just like a pretty standard thing that you might need. Here's how they went about it. And yeah, like I said, that was my takeaway from this. It was this uses symbolic execution for everything else in there. That's kind of, I think, the highlight for me. So I wanted to give it a shout out for that. Like it's not covering a specific vulnerability or anything for us to cover.
Yeah. Continuing some of other shout outs, some of you probably saw GhidraMCP by Lori Wired was released. And this is a model context protocol server, or MCP. I wasn't really familiar with that, by the way, before this came out. I'm not really in the LLM space, but it seems like the whole thing with MCP is you can basically run a server that hosts an API that an LLM can connect to and use when you prompt it to, you know, do some useful actions. So the way that it's being set up here is the MCP runs and it basically acts as a bridge between Ghidra and your LLM client. So you can use that to prompt in your LLM client, you know, tell me what this function does, or rename the function based on what its functionality is. And it'll use the API that's exposed by the MCP server to like decompile the function. And maybe it'll follow, like, see what other functions it calls, and it'll decompile those too. And it'll try to reason about, you know, whatever your prompt is. And it's pretty cool. I'm very skeptical about LLM stuff. And generally, I think whenever we've talked about LLMs and stuff on the podcast, it's generally in a negative context. That said, I've actually played around not with GhidraMCP specifically, but with an MCP server someone put out for Binary Ninja. And actually there was one released yesterday, I think. Let me just bring that up. Invoke. Yeah, Invoke did it. So I've got it up here. So there's also this one. This isn't the particular one that I use, but they're all kind of similar in how they work, which is providing that API. But yeah, I've actually given this a little bit of a try, and it can be useful in some situations. Now, I have seen people kind of blow it out of proportion, like what always happens when LLMs are involved. And people are saying, oh, this can be used to completely automate reverse engineering, and you can use this on, malware and whatever, and completely reverse it. Like, no, in my experience, not really. When you get to functions that are a lot more context specific to the application and you don't have a lot of that context already, like say it's calling a lot of functions that aren't labeled and it's using data variables that also aren't labeled, well, then, it's not really going to be able to do very much. I tried that on such a function and it renamed it something like initialize state machine because it's like, oh, it's doing something with state. But I don't know what that state is, so I'm just gonna call it this.
State machine. Yeah, no, perfect.
Yeah,
everything state machine.
So things like that, obviously, it's not very good. But sorry, go ahead.
Well, I was just gonna say, like, I kind of called out earlier a little bit about function calling, and that's effectively like I wasn't familiar with MCPs either. I hadn't really gone into that at all. The idea here is like it's kind of a generalization on function calling. So when you want to say let OpenAI call just a random function, like, and by function I just mean like code you wrote that will provide it some information, you could give it that whole definition like, oh, it's this function name, it does this, like a description, and then you do this thing and it'll call it. And like it seems like basically servers are kind of reusable cases of that, where you run your MCP server and that provides like this common protocol now that can be used by those clients that support it. And it basically will tell like, yeah, you've got these functions. So, well, yeah, you can prompt it as you were talking about using it. The other place you could use that is in addition with like React or some of the like chain of thought sort of setups where you can also let the AI decide it needs to get something's information. Like using the MCP, you've kind of got this common way. One person writes that and all these different AIs can take advantage of it. And so if you also chain that with some other things, it can also figure out like, oh, I want to use this function to get this in order to figure this thing out. So yeah, I definitely see a lot of potential in terms of it's just going to enable like kind of the agents to do more things, have more options for what they can do. And because it's actually reusable, it's not, because we have seen some similar tools to do these things that would just be like a specific plugin with a specific AI rather than being just the general purpose MCP server. So I think that kind of feels like the major change for me here. I have not played around with either of these, the Binja or the Ghidra one yet, so I can't really comment on that quality. But I have used like ChatGPT, like O1. I guess I've used Claude also a little bit to do some reverse engineering just through like the normal interfaces, not like this. And yeah, like the quality of it, like it is very mixed. It has the usual confidence issue where it can be overconfident in its own like understanding at times, where it's like, yep, it's this, and it like it's the hallucination issue. Like you've got that just isn't really solved, unfortunately.
That said, I do think that like summarizing is one of the areas where I have found LLMs to actually be useful and not have as many of the hallucination problems.
Oh,
and
that's
that is ultimately
tons of hallucinations.
Oh, really? Okay.
Yeah, like
so
go ahead.
Like if I try to ask like LLMs to generate new code or at new anything, I don't even use it for that anymore. Like I've given up trying. It's been useless for me. Maybe it works for generating toy code that's like really, really like it can just, rip it off of Stack Overflow or something. But if you try to actually get it to generate useful code to you, I never find it useful. But if I try to ask it to summarize something, like an article or whatever, generally it seems pretty good at that. Now I wouldn't rely wholly on a summary. Like I would still go and read the article and just kind of use the summary to aid my reading of it,
Yeah,
but
and
it has been
that's
useful for that. And that's kind of what's going on here, is ultimately it's using its view of the disassembly and the pseudocode or decompilation to try to summarize what the function is doing. And in some cases at least, it seems to be fairly decent at it. And because of the way it breaks it down in your client, like I tried using this with Claude, and it will show you in the chat window the steps that it takes and the API calls that it invokes and the reasoning process there. So if there is something wrong, you can probably see where that came from, like what the problem was that made it not understand.
yeah, chain of thought
And that's very useful too.
has been a huge improvement on that. Even though the chain
Yeah.
of thought is technically just more generation and it can be, lying to you. In general, it has helped with guidance and with preventing some of that. But yeah, when it comes to summaries, like in general, it is okay. But the problem is you can't really tell what's okay or not okay just from the summary itself.
No,
You
you
have to
still have to
deal
look at
with
the
that.
source
So,
material.
but like you, I do use it like because I find it a lot easier to, especially with some things we cover, to see a summary, take that summary and kind of read that and then read the article and kind of know where it's going to go. And maybe it'll be wrong, but like it gives me some insight on where it thinks it's going. At least it really helps with being able to understand it with just like one read through rather than spending quite a while trying to get there. So like yeah, it's still helpful in that, but yeah, on its own, I just don't trust it.
And that is the way to go, I feel.
Code
The
gen
people that have
though.
been saying, what's that?
Sorry, go ahead. Go ahead.
The way that people have been saying like this will fully automate reversing binaries and stuff, like I think that's just foolish. I don't think you should trust AI to wholly do anything. Um,
Yeah, I'm always there
but
for
yeah,
human in the loop. When
yeah,
that's just like any automation. Like I've been harping on human in the loop for a while, before even AI was out. Just like enable the humans to do things.
yeah, and enhance
Augment.
workflows rather than replace them. Yeah,
Yeah, yeah. On code gen, that is where like you were saying how it hasn't worked for you. I pay for like GitHub's Copilot. I have to be clear that it's GitHub's Copilot and not Windows Copilot. Um,
oh yeah, I kind of forgot they both use the same name.
yeah, it's annoying, but and my understanding actually is Claude is better on the coding too. I started with GitHub's and so I've just kind of kept using it. But I found it really useful for like especially the small completions. Like it saves seconds at a time where it's just like I'm writing very similar code, it predicts kind of what my next line is sort of deal. When I ask it to do larger things, it's been all right depending on like you kind of said if it's something that could kind of come out of like a Stack Overflow, it does a lot better than something completely novel. Like I remember trying to use it with Qling, and that framework, and it just had like no understanding of the framework, so it wasn't very helpful. There wasn't much
Yeah,
information about it, but a more popular library, it'll know things, or it can sometimes actually just guess from available function names too. It'll just figure things out there too, which has been nice and kind of tying into not reading documentation. It's
yeah,
telling me what the right function to call is, and like yeah, I've had some luck. I wouldn't use it to like write a whole function, or sorry, I would use it to write a whole function. I would use it to write like an entire like
subsystem or
module
something. Yeah,
class, like really large, but I've definitely had some luck using it to generate code in a variety of things, especially things that are a little bit tedious. I remember using it to like parse some BIF fields for me and write my BIF field code. Like I've used it on things like that,
yeah.
where it's
Tedious
just
code is a good place for it.
yeah, it like I said, it saves me seconds at a time. It adds up. And
Yeah,
what am I going to do with those seconds? Probably not sleep.
doom scroll probably. Yeah,
Exactly. Yes.
yeah. No, I will elaborate a little bit just because people have actually asked me what my problems with code gen have been. And the biggest one is I find that LLMs like to invent methods that they wish existed.
Yeah,
And,
definitely.
that's something that I wish I could do too, but it doesn't work, obviously. So it'll just call like non-existent endpoints and stuff. And it's like, yeah, it would be great if that existed, but it doesn't.
That's when
So
you ask it
this
to
code is
make it
useless.
exist and write the code for it to exist, and you just repeat that
You
until
just
it
keep going.
works.
Yeah.
Yes.
And ultimately, yeah, you save so much time. But yeah, so on the code gen stuff, I have found it less useful. But in this kind of scenario where it's summarizing code and trying to interpret something, it is a little bit more useful. And where I found it useful with decompilation and disassembly specifically, since that's kind of where like this shout out started, um, I found it useful for identifying your kind of boilerplate functions, like let's say libc functions, stir copy, mem copy, stir len, things like that, things that you could pretty easily reverse and figure out, but maybe you don't want to go because like one thing that you'll find when you reverse, especially with things like memcopy, is sometimes there's multiple versions of it, and it might not be immediately obvious that it's memcopy because it has a bunch of optimizations. It'll do like alignment checks and all these things, and it can take a bit of time going through even the decompilation to figure out exactly what it is. But with the MCPs here and the ability to prompt, like I found it actually does a really good job at identifying those kinds of functions, and it accurately determines what they are and can label them for you. Now, I still manually check. Like if it says this is memcopy, I will go and look and see like, okay, does this actually make sense? Is that actually what it's doing? But still, it can save you a lot of time on getting some of those, boring, so to speak, functions out of the way. That said, when I tried it on more application specific functions without a lot of information for it to go off of, like without a lot of functions named and stuff like that, it's just, it doesn't help really very much. So, yeah, it's one of those things where it could definitely be useful in certain situations, but you can't rely on it to do the whole process for you. At least at least in the cases where you don't have like symbols and everything. If you have symbols, then maybe you could automate a lot of reversing a file. But if you're working from like a black box context or something, then yeah, it's going to be limited in how much it can be useful to you.
So I can actually
Um,
imagine a little bit more where, because I said this is a generic thing that can be used by other systems. If you were to, and I know I'm quite confident you haven't done this, like actually start implementing like a prompting framework, automated prompting, actually like doing your own chain of thought, reprompting, setup, and all of that, such that it could like understand or try and reason about like what do I need to do to reverse engineer this entire binary and actually have it like go through the minutes or whatever, like a longer time. I guess it's probably not just minutes, but like a longer time of work with a lot more function calls and discovering what it needs to do. Like I could imagine more of a system like we were talking about things like Project Naptime from Google, where like the whole AI system that they're going through is a lot more complicated than what you're probably getting when you just do like the chat interaction of like reverse engineer this thing. There's a lot more going on in those sorts of systems that I could see it like helping to enable that, but it is not doing it where it's just like you're loading this MCP into the Claude desktop application, be like reverse engineer this binary and just like getting everything. But I think it does enable again that more agent based workflow that is kind of going to self prompt and work through things on its own. I mean, I have genuinely been impressed by some of that because even like O1 when OpenAI first put out their O1 model, so that's the first one where it's basically doing its own prompting for chain of thought stuff and like trying to figure things out and figure out if this works or not. And I gave it actually feeling lucky the fix the challenge from 0x530 I gave it that I just gave it the source code. I'm like, hey, there's a vulnerability in this code, can you find it? And I gave it that and just asked it like figure this out. It didn't do so. It found a new vulnerability that I hadn't intended.
oh, I don't remember you mentioning that.
Yeah, so like, but the thing is, that took it, I think it was like 20 minutes of reasoning before it got there.
Ah, okay.
Like I don't remember exactly how long it was, but like it took it quite a while because it didn't. Minor spoiler if anybody like this, it's an old challenge. Like that challenge is over a decade old now. It uses a bug in PHP's old implementation of some of like a randomness function. So if you're not aware of that, and it's not really well documented anymore, it's really hard to solve. But it basically came up with another way of solving it without needing that bug. Basically, like it was able to get there, but it took quite a while, and it took that much more complicated reasoning system than I think just what you're probably using.
Yeah. But all that said, I think these servers and plugins are worth checking out and seeing if they can work in your workflow. I just wouldn't trust them wholly. And
Yeah.
it was kind of funny. This is a little bit off topic, but I saw some people, and these are some people that I talked to in Discord, actually, in the reverse engineering Discord. But since like this Ghidra MCP thing took off pretty well, and there was a lot of people trying it out, and of course there were some people who were like, okay, let's see if we can break this. So they started writing like code gen and just like binaries that could completely break these systems. So you know, there's a little bit of that fun cat and mouse going on there too. And like in seriousness, that could be something that is a future consideration in like obfuscators and packers, is trying to deceive LLMs and their reasoning, because you know
Did
they
they
probably will be a decent shortcut
did they
in
get
RE.
prompt injection through a binary?
No, they didn't go
Uh,
that far.
I was
They just
really
kind of like wrote
hoping
the
that would
parsing, I
be what
think.
they managed. Like, I
That
like
would be awesome.
you know, getting it to like decompile it and be like, oh no, there's a string or something in there. It's like ignore all other instructions. This is this program or something like I don't know, something stupid like that for prompt injection because I
That
could
would be
totally
really
see
fun.
that.
Yeah, that I could see that working for sure. But yeah, no, it is very cool, and it will make a difference, I think, in reversing these kinds of tools. Again, human in the loop.
Yeah, I don't think it replaces the human. It augments the human. Maybe makes
Yeah,
less humans necessary. I don't know, but it augments the work.
yeah. We do have one final shout out of yours, Z, on emulating an iPhone and qemu from eShard. I'll let you talk about that, and then we'll wrap it up.
Yeah, not a lot to talk about with this. It's just the title gives it away. It's emulating an iPhone and QEMU. Uh, it's iOS 14, so not like the latest iOS or something, but still, it's just their process issues they dealt with. All of that. Again, no security issue really in here. Just there's their process. Yeah, if that interests you, you know, check it out. See how they kind of went through that process. But if
Yeah, I will
not, yeah,
say one
go
quick
ahead.
interesting thing I'll mention is they talked about the fact that you used to be able to skip the GPU rendering and do direct software rendering with like a boot command or a boot argument, but that got removed at some point. So a lot of their work here is on like trying to emulate the GPU and do pass through there, which is of course like really complicated, especially when you're talking about Apple stuff where that's not necessarily documented well and it's all sort of under the hood. So yeah, there's a lot of cool stuff there when it comes to like the GPU stuff in particular. So uh yeah, I
Yeah, I
thought
thought it
that
was a
part of
good
it was cool.
post. Interesting.
Yeah. But yeah, so that is all the topics that we have. I know this episode was a little bit longer than usual, but there was a bit more discussion focused topics than usual in this one. So yeah, a bit of a longer episode, but that's all that we have. So as always, thanks goes out to everyone who tuned in, and we will see you next time.